angular acceleration. It's a very much as linear acceleration, you might say, rotational analog of linear acceleration. It's represented by letter alpha, and that's rate of change in angular velocity. It simply tells us how fast is the angular velocity changing and in which direction it is changing. You see, we have equation for linear motion. These are 3 in number, v equal to u plus at and so on, s equal to ut plus half at square. Likewise, here also we have the equation for angular motion. In place of final linear velocity, it's going to be omega 0 plus alpha t, and here also we are having the analog for second equation also. Similarly, third and fourth equations that has been compared over here. So all the equations that we have in linear motion are exactly transformable in rotational motion. Now, one very important quantity that goes in rotational motion is torque. Torque, that's represented by Greek letter tau. This one. Tau is rotational analog of force. This might be written as R cross F. You see, when we say it's a rotational analog of force, it simply means force can there change the state of linear motion, whereas the torque can change the state of angular motion that we call here rotational motion. Suppose one body is subjected to this axis of rotation and it is applied a force at this very point, force at point P. This is axis of rotation. The distance of the point from the axis is given by r, that we call radius vector here written. And force is applied over here. Then the cross product of the two is going to be the torque. Now a little change, geometrical change in this figure. Draw a perpendicular from the axis. This is known as perpendicular distance. Perpendicular distance between the axis of rotation and this force, or you might say R and F. See, this angle is theta. This will also be theta. And from that point of view, you find here R upon R equal to sine theta. Capital R you get equal to R sine theta. Capital R is going to be said as moment R. This is also known as perpendicular distance of axis of rotation from the force. If you elaborate this relation, you find R F sine theta N. This torque. Torque equal to, simply we are taking numerical value only, then it becomes F R sine theta, replaces by capital R, it becomes F into R. Now that very relation is converted in this numerical form, simply no direction. You could say it is the product of force and perpendicular distance from the axis of rotation. Since it is also called moment R, we can say that torque is moment of force. This is very often, this term is used, moment of force, that we have written here. And theoretically it is defined as the product of force and perpendicular distance. Very much numerical. When you want to be, you could say this is the product of radius vector and the force vector. When the torque produces anti-clockwise rotation, anti-clockwise effect, then it is considered as positive, and if it is going to the result clockwise rotation, then we would call it negative.